Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. You must have been waiting for me for the physics lecture, for the next physics lecture, you can say it. And we have completed describing motion. And in that describing motion, the numericals were still left. So there are very easy questions coming ahead of us now. Now the question starts from it is page number 23 of your book. This book, we have this book, your course book. Okay. Now page number 23 and question number 4. Uh, Question number 1, 2, 3 have already been done by me. So question number 4, an aircraft travels 900 meters in 3 seconds. What is its speed? Now, my dear student, it is very much easy question. Questions or numericals? Numericals. So question number 4 says that an aircraft travels 900 meters. Now, what is 900 meters? It is the distance, which is 900 meters. Okay. And what else is given? Time is 3 seconds. So, no problem with these two. Meters per second. We'll get the answer in meter per second, and we have to find what we have to find is its speed. So, I've already told you S is equal to Vt, and a triangular formula S is equal to Vt. And when we have to find V, we just divide S with T. So it is very easy. V is equal to 900 meters. Write the units with them, okay, and divided by 3 seconds. Then in the end, you will not try to find the what will be the unit. So here are the units. Okay, now here are the units, meter per second. Okay, now it is divisible by 3. So 3 times 9 and 0. So the answer is 300 meters per second. The speed is 300 meters per second. Okay, now the next question is a car travel. It is same question. What is speed of the car in yes, but there is a little difference in between the two questions. So I'm going to tell you what is the difference. So here is the key to these questions. This is the key to your questions. So my dear students, question number 5 now. Now in question number 5 there is a little trick they have played for us is a car travels 400 kilometers. 400 kilometers. Now what is S? It is distance 400 kilometers. Now you see it has come in kilometers and we have read in meters per second. Okay, and in time is also given again. It is how much? 3.5 hours. 3.5 hours. Okay. And what is the speed of the cars? What is the speed of the car? We have to find the speed of the car in kilometers per hour and in meters per second in both the units. In both the units. So here the first part is very easy. If we just consider this triangle, you see V is S upon T, S upon T is already been there. Just divide these two. Just divide these two. You see that it will become in kilometers per hour. So let me divide it. So it is very much easy. Just divide this with this, but in the next step. Okay. Uh, so 400. I'm just giving you the short things. So it will become 400 divided by 3.5. Now it will become 114. Now this will become 114 point almost, it is 0.28. I am going to write it 0.3 kilometers per hour. Okay. Now this is the answer for this first part. But what about this? What about this? We have to change this into meters and this into seconds, because this is in seconds. This is in hours. So what is the formula? You know the formula for kilometers. You have to change, when you have to change the kilometers into meters or meters into kilometers, you have the formula. But what about this hour? Now in 1 hour, you know that in 1 hour there are how many? 60 minutes. Okay, there are how many? 60 minutes. And in 1 minute there are 60 seconds. No, this is not like 100 or 1000. These are 60. The unit is 60. The smaller unit for hour is minute, which is 60 minutes for 1 hour and 60 seconds for 1 minute. So you see that we have here are 3.5 hours. Now what about 3 hours? Now let me take about first, I take 3 hours. Now 3 hours. 3 hour means we'll multiply it with 60, again multiply it with 60. That means I have to multiply it with 3600. 3600 to make this 3 hours, to make this 3 hour into seconds. So why I left it? I am going to tell you. Don't be afraid. I am going to tell you. So 3 hours. 3 hours. 3 multiplied by 3600. So it will become 0036 times 18 and 3 3s are 9 and 1 10. So these are 3 hours. These are 3 hours. 3 multiplied by 3600. 10,800 seconds are there. 10,800 seconds are there. Now what about this point 0.5? Now what does 0.5 hour means? 0.5 hour means 30 minutes. Because this is 5 hours. 0.5 hours. 0.5 hours is how much? This is like this. This is like this, 0.5. This will be 0.5. Okay. So it will be 30 minutes. Again 30 minutes. We have to multiply 30. Now these are the 30 minutes. So we have to multiply it with 60 only. Because these are already 30 minutes. These are 30 minutes. So we have to take them into seconds. So it will be 1800. So just add these 1800 also over here. So it will become 12,600. 12,600 seconds. Now these are seconds. 12,600 seconds. And what about the kilometers? Now kilometers into meters, just multiply it with 1000. It will be changed into meters. Now these are meters. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and 400,000 meters. Now these are 400,000 meters. This is 12,600 seconds. The formula will remain the same. So V is equal to S is 400,000 and T is 12,600. Subtract these two zeros with this. So you are left with 4,000 divided by 126. 400, 4,000. divided by 126. So our answer will be 31.75 meters per second. Meters per second. Now this is in meters per second. This is V, which is 31.75 meters per second. And what was it in the kilometer per second? Kilometer per hour. This was in kilometers per hour. 114.3 kilometer per hour and 31.75 meters per second. Okay, it is the same question with 2 units. Now question number 3. Here it is question number 6. Okay, question number 3. What is question number 3 for today? A Voyager spacecraft is moving 17,000. Now V is given. How far will it work in 1 year? Give your answer in kilometers. Now it is a very large calculation. A Voyager spacecraft is moving at 17,000 meters per second. Now it is V is given. Okay, V is given over here in question number 6. V is given. V is 17,000 meters per second. Don't just bother about what is it. Is a Voyager, it is a spacecraft, it is a car, it is a train. Just uh, bring out the data from your question. Bring out the data from your question. Now I have taken the. Now this is the only data which is given to you in your question. V is equal to 17,000 meters per second, and what I have to take out is how far will it travel. Now how far will it travel when t is given? T is also given, but in English, 1 year. 1 year. And what else is left? S. S is left. So we have to find this S, distance. Time is 1 year. And also give your answer in kilometers. Now I have to find this in kilometers. In kilometers, meters per second. Now this is given in meters per second, you see. This is given in meters per second. When this is in meters per second and you are asked to calculate this question into kilometers, you have to change this. You have to change this into kilometers per hour. You have to change this into kilometers per hour. Okay, now, because this is the time span is very great. The time span is very much great. So I have to change this figure. I have to change this figure into what? Into kilometers per hour. Into kilometer per hour. Kilometer per hour. So how I change it in kilometer per hour? So you see this is 17,000. It is 17,000. Just forget about these. These are meter per second. Okay. Now I have to change it into kilometers per hour. Now how do I do it? You see this is 17,000 meters. When it is meters and I have to change it into kilometers, that means we have to divide it with 1000. With 1000. Okay. Now since it is 17,000, oh here it is the time is 1 year. In 1 year, in 1 day, you can say in 1 day there are 24 hours. In 1 day there are 24 hours. Okay. And in 1 year there are 365 days normally. Normally there are 365 days. There is a 360, but that is a leap year. So just multiply this with 24. Just multiply it with 24. So it will become 24 multiplied by 365. 8760. Now these are the hours. These are the hours in 1 year. These are the hours in 1 year. 8760 hours. So we have already hours with us. We have already hours with us. We have changed uh, the meters into kilometers. Now it will stuck with this. So there are only 17 kilometers. 17 kilometers. But we have to also change this into hours because this is in seconds. You know that in 1 second it is traveling 17 kilometers. So that means in 1 hour it will travel like this. So it will be, because this is in seconds. This is in seconds, and from second we have to change it into minutes, and from minutes I have to change it into hours. So from second to minute is 60, and from minutes to hours 60 again. So the total will be 3600. So it will be 17 multiplied by 3600. So it will become 61,200 kilometers per hour. Okay, kilometers per hour. 61,200 kilometers per hour. Now, how far will it travel when we'll multiply? Now, what is our formula? What is our formula? S is equal to Vt. S is equal to Vt, and we have to find S now. We have to find S now. When we have to find S is equal to Vt. So is given. V is 61,200 kilometers per hour, and where is T? 8,006 hours. So you see, this R is in denominator, this R is in numerator, and this R is in denominator. So these two R's will cut down. These two R's will be struck off. So we'll have to multiply this with this. Simply this with this. 61,200 multiplied by 8,760. So it will become a very large. I told you that it will become a very large figure. 536,112. So S is equal to 150 112 with 3 zeros kilometers in 1 year. These are this distance covered by a spacecraft in 1 year at this speed. So my dear students, this is the distance which will the Voyager or whatsoever it was spacecraft will travel in 1 whole year. Now, what is this? This is almost 536. 536. You can say you take this only 536 million kilometers. You can write it like this. 536 million kilometers. Now, question number 7. Question number 7. Calculate how many minutes it takes sunlight to reach us from the sun. Light travels at the speed of light. It's number 7, speed of light. In fact, it is the approximate speed of light. The actual is a little lesser than this. The speed travel at the speed of light, v is equal to that is 3 into 10 raised to power 3 into 10 raised to power 8 meters per second. And sun is about 144 million kilometers. S is equal to how much? 144 million kilometers. Okay, now what we have to find is T. Now we have to find T in minutes maybe, or in seconds. Yes, we can find it in seconds and then we can change it into minutes. What is this? This is in kilometers. So what is million kilometer? You have just seen in my previous that there were 6 units ahead of million. Okay, that was 536. That was 536 million kilometers. And when I wrote it in, so I have to put 6 zeros ahead of it. 6 zeros ahead of it. So what is million? This is unit. This is 10. This is 100. All the three complete. Now for thousand, this is the unit for thousand. Okay, 10,000. Again, 10 for thousand and 100 for thousand. 100,000. These three are complete. Unit 10,000. Same format will apply over here. Unit 10,000. Now this is the unit for thousand. This is 10 for thousand. This is 100 for thousand. Okay. HT. Now for this we have changed. It is unit. It is thousand. And what is coming next is million. So it is million. Again, you see that unit, unit for million, 10 million and 100 million. And similarly, billion. Now the billion will come. B, PB and HB. Now we don't have this much large figure over here. So we have only this much figure. So what will be 144? Now this is 100 and this is the unit. 100 and 100. The rest are zeros. Like here. 5, 6 zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 zeros. Okay. Now we have to change this into meters because we are given the speed of light in meters per second. Okay, now. So what will we do? We'll just multiply it with 1000. So for 1000, the figure will become this one now. More large. This is in meters now. This is in meters now. See how many zeros are there? There are 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Now, what is the simple formula? S is equal to Vt. What we have to find is T. What we have to find is T. So, T is equal to S divided by V, which is equal to S is this. A long figure. Okay. Now, you can write it like this also into 10 raised to power 9. And also you can put a point over here and increase, but I don't need to. Okay, and what is this? 3 into 10 raised to power 8. 3 into 10 raised to power 8. So I manipulated the values. So these 8 will be cancelled with this. Okay, only 1 will left. So 1 we don't write 1 over here. So it means that we are left with 1440 divided by 3. So what is this? 1440, 480. It will become 480 seconds. 480 seconds, because the speed of light was given in meters per second. Okay, it is 480 seconds. Okay, now, and if you want to, you see that this was in meters per second, and this was in meters. So this will cancel with this, and because this is already in the denominator of the denominator, so it will rise up over here. So it will become seconds here. It is in meters per second. It is in denominator. 3 meters per second. So it will jump up over here. So it is in second. If you want to put it into minutes, so you have to divide it in with 60. So 6 8 are 48. 8 minutes. So if this is the sun and this is the earth, it will take 8 minutes to reach the first ray of the sun to the earth in 8 minutes. In 8 minutes. The distance is 144 million kilometers. 144 million kilometers. Where the speed of light is 3 into 10 raised to power 8 meters per second. Okay, I hope you would have understood this. So, my dear students, the last question is coming up now. Now, in this last question, there are many questions. There are 4 questions in this last question. 4 parts of this question. Okay. Now, the question, you can read it by yourself. 8. Question number is 8 now. Question number 8. Okay, we'll do them part by part. A cheetah can maintain its top speed at 31 meters per second. Now, top speed V, you can say it V1, that is equal to how much? 31 meters per second. Whatsoever is given to you, just write on your notebook. Over a distance of 100 meters. Over a distance of 100 meters. So, you have to understand this question. When cheetah will start running up to 100 meters, it will maintain 31 meters per second. Up to 100 meters, from here to here, it is 100 meters, and it will maintain 31 meters per second. Okay? Over a distance of 100 meters per second. Now, what is the distance? S is the distance. That is 100 meters per second. 100 meters. Okay? While some breed of gazelles, such as Thompson gazelle, have top speed of 25 meters per second. Now, this was the speed of cheetah and gazelle. A deer, it is a sort of deer, you can say it. Gazelle. Such as Thompson gazelle have a top speed of 25 meters per second. Now, this is the speed of gazelle, Vg. Speed of gazelle is 25 meters per second. I hope that my board will be filled up with the data now. The question is considered how cheetah need to catch the gazelle if they are both just reach the top speed. Now, this can run 25 meters. This can run 31 meters per second. So you see, obviously the cheetah will catch the gazelle at some moment, at some. Okay, what is it? How long does it take? Now question. The part is A. Part is A. It says how does it take cheetah to cover 100 meters? 100 meters. It is 100 meter. So it is very easy. I told you that if this is 100 meter, he will maintain this speed. He will maintain this speed. So it is very easy. By this formula, again the formula S is equal to Vt. So V is given, S is given. So you have to. So for cheetah, I am going to see it Vc. Okay. Now time C. Time the cheetah will take. For C, I am going to take theta. Okay. Tc is equal to S. S. What is S? This is S. 100 meters, and this is 31 meters per second. You see, the second is again coming in the denominator of the denominator. So it will jump here when it will be crossed. So it will like this, and the answer will we have is 3.23 seconds almost. 3.23 seconds. 3.23 seconds. When you divide this, you will get 3.23 seconds. Now, the cheetah will cover the distance of 100 meters in 3 seconds, almost 3 seconds. Okay. Now, B. What is the closing speed of cheetah? Now, what is the closing speed of cheetah? Now, what is he going to do with this gazelle? Now, there is a deer or gazelle over here, and here it is cheetah. Okay. Now, both are running. He feels the danger that cheetah is coming. They're running. He's running. He's running. The both are running. Now, how far will it take it? What is the closing speed of cheetah? That is, what is the difference in speed between cheetah and gazelle? What is the difference between closing speed of cheetah? Okay, now you see that this is 31 meters per second. 31 meters per second. Now, if he want to catch this, this is the initial speed, and this must be the closing speed. So, when he will come across this gazelle, the speed should have been reduced to this much. Okay, this is the initial speed of the cheetah. This is the initial speed or speed at which he can maintain for 100 meters, and this is the initial speed of gazelle. So he will break his speed to this. He will break the speed to this. Now this is the difference between the speed of cheetah and gazelle. So Vf, you can say it, that will be Vc minus Vg. Vc. This is the closing speed. Okay, this will become 31 minus 25. Both are in meter per second. It will become 6 meters per second. 6 meters per second. Okay, this is 6 meters per second. Understood my point? Now this was B and C. What is C? How far ahead the cheetah would gazelle need to escape? Hint, you would need the time to calculate in A and the closing speed calculated in B. Now they have given us a hint also that we have to take this time and this closing speed. If the gazelle wants to escape, if the gazelle want to escape, what is the distance between the speed and cheetah? How far they need to escape? Now, how far it should be? I put 2 points over here. This is G, this is C. Now, how far should it be? How far should it be to escape from this cheetah? Now, they have given us hint that you use the closing and you need to calculate it in else. Yes. Now, we have to use this time and this closing speed. This time and this closing speed to calculate our C. Now, what is C? Okay, how far ahead? Okay, or how far ahead? Now, lead distance. It is called lead distance. Lead distance. It is called lead distance just to escape. Just to escape. Now, if he want to escape, what should be the distance? For example, here he can catch. Here he can catch the gazelle, but here he cannot catch. What is that distance? What is that distance? So he is. The book has also stated that we will use this speed and this time. This speed and this time. So how will speed this speed? We'll use this closing speed multiplied by time. So it will become, what is the closing speed? Closing speed is 6 meters per second. And time is how much? 3.23 seconds. 3.23 seconds. Now this second will cut this. Okay, it will become almost 18. Almost 18 or 19. 6, 3 times 18, and let it be almost 19 meters. Let it be almost 19 meters. Okay, it is 19 meters. Now, what is the, how long would it take to the cheetah to catch the gazelle with closing speed you calculated in B and the distant part you calculated in C? Okay, now this is the lead distance 19, which we have calculated in C. We have to keep all the answers with us. Now this is the answer we have to keep. This is the answer I have to keep. This is the answer we have to keep. Okay, now this is 3.2 and this is 6 meters. This is 19 meters. So in D, what we have to find is, now D, now in D we have to find how long would it take to cheetah to catch the gazelle with this closing speed you calculated in B. Okay, now what we have to find T, time, with the distance apart, which is in we have he now this hint has been given to you. Now this is distance apart, or the lead distance apart divided by closing speed. Okay, now this is the closing speed. Now these hints are given into your book with the question. Okay, closing speed. Okay, this is 19 divided by 6. Now this is 19 is in meters. This is in meters per second. So this meter will cut and this will come over here, jump over here, and this will become 6 3 times 19, and this is almost the same, 3.23 seconds. Okay, my dear students. Your questions have been completed. Time to say you goodbye. Allah Hafiz.